Hello, everyone. My name is Timothy Lee Grant, and welcome to a midnight Leet coding session. This will be fun. All right, got off work, was too tired to immediately start a Leet code, and now it's time. I promised every day we're going to do Leet code, and we are focusing right now on depth first search. We're going to get good at depth first search. We're going to keep doing depth first search problems until we can get to the point where almost any medium is doable. I feel like I can handle any medium. So, without further ado, let's randomize which one we do. So, let's see what's up. It looks like we are doing accounts merge. Okay, here we go. Number 721, accounts merge. All right. Given a list of accounts where each element, accounts of I, is a list of strings, okay? Where the first element, accounts of I0, is the name, and the rest of the elements are emails, representing emails of the account. Okay? So we're given a list of accounts, and this is a two-dimensional array. The first element of each, or the 0th element of each account is the name of that account, and then the 1 to n rest of the elements of the account of each individual account is the emails represent is okay. And the rest of the elements are emails representing emails of the account. So this account has multiple emails, maybe? Okay, anyways. Now we would like to merge these accounts. Two accounts definitely belong to the same person if there is some common email to both accounts. Note that if two accounts have the same name, they may belong to different people, as people could have the same name. A person can have any number of accounts initially, but all of their accounts definitely have the same name. Okay? After merging the accounts, return the accounts in the following format. The first element of each account is the name, which is already what we have in this accounts two-dimensional array. Okay? And the rest of the elements are the emails in sorted order. What does sorted order mean? Like alphabetical order? The accounts themselves can be returned in any order. Accounts equals, okay, John, and then a bunch of emails. John, and then a bunch of emails. Okay, Mary, and then one email, John, and one email. John Smith. So I'm noticing that this email here is the same as this email here. So that means these two Johns have to be the same person. And so therefore I merge this John to be the same person, and I keep all of the unique emails which are associated to John. Okay. And then Mary, there's no other Marys here. So that means that Mary, I don't need to merge anything with Mary. Okay, so what I think this question is asking me to do is I'm going to be given a whole bunch of different accounts, and each of those accounts are going to be different people. Now, these accounts can have any number of emails associated with them, and I need to check each account, each person, and see if there are any duplicate people. And the way that I determine if there is a duplicate person is if the email is, if there's any common email. If there's a common email, I know for sure that that is the same person, and then I merge that person and all of their emails. So it's the same person, but then I take the emails which belong to both separate accounts but the same person, and then I put it into one account, and have all of the emails which are unique. They have to be unique emails. Okay, so let's try to go about solving this. All right. So I guess what I'm going to do is I am going to create kind of like a hash table, or let's see. So I guess results, okay, equals like this. And then my idea is I'm just going to iterate through each of the elements in this account, and I'm going to check if that element, or if that email, is in results. No, because I can't. So this dictionary has like key value. I cannot search for a value. I can only search if a key is in this dictionary, and if it is, I can search the value, but I have to know the key. So that actually doesn't work if I'm trying to see if a email is present or not. So actually what I think I might need to do is something like this, where I have seen emails equals, and then like a set, okay? And then I'm going to add this, I'm going to add emails to this set, and then I'm going to ask, okay, have I seen this email? Have I seen this email? Have I seen this email? And then if I have seen this email, I'm going to look at the name and try to add that to the associated name that I've already seen before. So what I mean by this is kind of like this. Let's see. So I have a list of. Can I minimize myself a little bit more? No. Okay. So I have a list of a list, which is string type. Okay. And it returns a list of string type. Okay. So what do I want to do? Like for account in accounts, I want to iterate through each of the elements in that account. So email in account. Whoops. For email in account. Okay, so what am I doing right here? Accounts is a list of lists, right? So if I take one element, I'm doing element by element. So I take an element from accounts, and that is going to be account. Now, what is an element of a list of a list? It is a list, right? So accounts is a list. Now I just iterate over each element in the list here, accounts, which what is that going to be? That is going to be the emails. Okay. But the first one is actually going to be the name. Yeah. How do I determine if I'm at the first one? Okay. I remember seeing this kind of interesting method for doing, like, you get the element and also the index, but I forgot how they did that in Python. For email in, was it like email something like this, and Python just knows what you're asking? Hold on, this is like this is just a syntax kind of thing. Let me see. I want to get each of the elements in account and also get the index. How do I do this in Python? Okay, let's see what it says. All right, enumerate. Okay. Enumerate and then accounts. Cool. Is that a keyword? Yep, good. Spelled it right. And then I think they had index first. Like that. Is that correct? Index first and then the element. Okay, cool. So now, if it's the first one, I'm going to add. Okay, so if index equals 0, what am I going to do? I'm going to say current name equals email. So if we're at the first index in the list, so right now this is account, and the first index, the 0th index, is going to be John. Okay, so if we're at index 0, we store John as the current name. If it's not, we need to check if this email exists in seen emails. Okay. Else, okay, if email in seen emails, we do something else. We want to add that email to seen emails. Seen emails dot add. Okay, so what I'm doing here is I'm going to, in this else case, it is we know that we're looking at one of the emails in a particular account. Now I'm going to keep adding emails, or each time I come to a new email, I am going to see, have I seen this email before? If the answer is no, I've never seen this email before, I need to add that email to the list of emails that I have seen. And then I need some way to keep track of this account. Would I just create another list, like a list of a list? And then, let's see, so maybe here I have currently working is an empty list. And then okay, so I'm building a list for each account, and then if I see a email that I've already seen before, then I need to merge them together. If I have not, I have to add. I have to keep creating this currently working list, right? I'm realizing that there is a flaw in what I'm doing because again, just as I said with the last video that I made, this does not seem like a depth first search problem. This is not anything of what I'm used to when it comes to depth first search. This doesn't even look like a graph problem. This is a weird one. The last one, I had to go through it and try to understand what was going on, and I saw, like, okay, I'm adding elements to a stack or a queue. If it's a queue, then it's oh, come on, I just did the video about it. So queue is that you are seeing each of the nodes in the order that you saw them. So that would be breadth first search. Stack would be depth first search because you're seeing or you're processing the most recent node that you just saw. So stack is depth first search. Queue is breadth first search. So in the last video, I processed like how I can do the iterative method for depth first search and breadth first search on a problem that didn't even seem like a graph problem. This one also does not seem like a graph problem, but it seems very different than the one that I just did. So, where's that? Well, what I'm thinking is I'm running into a problem that okay, if I see the email, if I've already seen the email, then I need to merge all of the I need to merge the list with if I've seen the email, I need to merge the list and I need to not just keep appending emails to currently working, but instead I need to actually like add that email to the other list, like the combined list now, not this currently working. And I also need a way to make sure that I don't combine emails that I've already seen before. What if I just do something like this, where that's gonna suck. That's not a good solution. The solution I was originally thinking, or just thinking of, like 2 seconds ago, was what if I just have a flag here that says like, "Hey, I've seen this list." So then, at the when I break out of this for loop, I just check if that account, like that currently working list, should be appended, like combined, and then I write a separate like helper function that combines the two together. But then I would need to have some way to determine if I've seen that list or that email again, and I've already added an email to the scene. I could just create a second set. I mean, I could do something like this. Currently working is an empty list, okay? And then I do what? I just create a flag. So if the index is 0, what is the purpose of this? I need some way to be able to associate which name that email is a part of. So if there's like 3 Johns and the second John has an email like whatever, John New York, okay? And then the fourth John that I see also has an email, John New York. It will be in my seen email set. Oh, we hit midnight. There we go. It's the midnight Leet coding session. So John New York will be in my seen emails set, but I don't know which John to associate it with. How do I know that it's the second John? Which again makes me think of a dictionary. But I can't say like if email in and then look up the value. I need the key. but the key is the name. And I can't flip them. I can't say like, I can't say like I'm gonna have the emails be the key, or could I? What if I have something like this? So like this, where key and then val. So value is index of person, and then key is going to be what? Email. So each time I see an email, I'm going to add it to the dictionary, and I am going to associate the index, which means this index, so which account I'm looking at. I think actually this might work. So I actually want to enumerate accounts, and then I want account index and account. I'm just going to get rid of this, all of this. So I still want to iterate through each email. So email index. Email index. Okay, so what do I want to do? There's all these random hairs all over the place. Okay. So I want to add, so this just solves my problem of determining if there is an email in that I've seen before. It doesn't solve the problem of not concatenating, but combining them together. So I took one step forward, 3 steps back. Yeah, I'm failing to see how that actually helps me. What if I did have something? I don't know. I'm currently working, which I said was an empty list. And then I do something like this, which is if email in, then want to do in this portion? I guess I just set a flag, so known person equals account index. No. It equals what? I want the 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 value of this dictionary. So I want my dict, and then email is going to be in here. So I have a dictionary. I'm giving it the key, and then that will return the value. So now I have the index. Okay. So here I'm going to go known person equals -1. So this is how I'm going to determine if I've seen the person before. If known person equals -1, then I know that it's a new person that I haven't seen. If known person had been changed to something above -1, so either 0 or a positive number, then I know that I have seen it, and I know that I need to merge it with the index known person. But I don't have a way to keep track of known person. My goodness, this problem, it's just like you think that you're getting even a little bit moving forward, and then you just get blocked. It's like, so the problem that I'm realizing now is, okay, I have the index in accounts, which I need to merge with, but when I'm creating a new list, that doesn't, when I'm creating like the answers list, that doesn't necessarily correspond to the same index, because your output is going to have equal or less accounts in it because you're merging accounts. Darn. I thought I was onto something. Okay, come on. Why can't I even think of a possible solution for this one? If email in my dict, then I know it's a known person. Okay, I can't figure it out. I have no idea how to do this one. No idea. I'm gonna have to cheat. Alright, here we go. I have no idea. Okay. So, to solve the problem of merging accounts based on common emails, you can use a graph-based approach or union find. Okay, so apparently we can do, uh, there is a graph method or algorithm which we can use to solve this problem. Or we could use union find. I've never heard of union find. I have no idea what that is. So I guess we're going to learn. That's gonna be fun. Okay. So here's a high level plan using union find. Okay. Steps to solve. Initialize data structure. Use a union find data structure to manage the merging of email groups. Use a dictionary to map each email to a unique identifier. Okay, I have never heard of a union find. Does it like explain what a union find is going to be? For accounts and account, it's a union? Is this a, hold on, is this like a Python keyword? Union? Doesn't seem to be a Python keyword. Did I like misspell it? Oh, all of my videos. I meant to click this one. Did I? Okay, it's not some kind of like keyword, so it must be like a function that was defined. Part of the solution. Anyways, build the graph union, traverse the accounts for each account, unify the emails. If an account has multiple emails, ensure that they are part of the same group. Okay, I'm gonna have to get like the and this is not the full code, is it? Oh, it's just like broken up. I'm gonna have to look at the code because I can't understand what the English is even saying. I don't even know what a union find is. Was this like one of the? I'm gonna check. Like, is union find find a data? Okay. Yes, union find, also called disjoint set union, is considered a standard data set. Okay. Interesting. I mean, I'm glad that I found out about it, right? Like, but I'm also kind of confused how it slipped my radar for so long. But thank goodness I was able to, thank goodness we landed on this problem, and thank goodness I said, like, hey, I can't solve this. And I went and I searched, and now in the autopsy portion of this video, we're going through, like, hey, why did I fail? What was the problem? And bam, we found a completely new data structure that I had not even heard of before. And now we can add this data structure to our tool set, moving forward. So, I mean, I'm really happy that I was able to find this new data structure. So, find components. After building the union, iterate over the emails and group them based on their root representative or parent in union find. Output the merged accounts. For each group of emails found, collect the corresponding emails and their associated name. Oh my goodness. Probably also doesn't help that it's late. Then sort the emails and format the output as required. Okay, sure. Key data structures. Union find. Disjoint set union. This helps in efficiently managing the merging sets of emails. Email to name mapping. A dictionary to map each email to corresponding account name. Email to ID mapping. A dictionary is a dictionary to assign a unique identifier to each email. Okay, here's a high-level pseudocode outline. Initialize the union find structure. So we have a whole bunch of dictionaries. Parent. To store the parent root of each email. Rank. To manage the rank for union by rank. Email to name. Okay, so this is kind of how they're mapping that. To map emails to the corresponding account name. Email to ID to assign. So they're using a ton of dictionaries to try to keep track of all those things that I was saying, like, hey, I'm losing this information, I'm losing this information. They just create a whole bunch of dictionaries. That's their solution. Not bad. Not bad. Okay, yeah, sure. Union emails in each account. So for account in accounts, okay, we get the name, which is the 0th index. Okay, good. For email in accounts 1 through to the end. So we're iterating through each of the emails. That's almost identical to what I did in this right here. So I'm iterating through each of the accounts and I'm getting the email. Good. So then I'm trying to figure out what this union right here is. I know we skipped all this, but I'm just trying to figure out, like, what even is this? Is there... Because union was not a standard, like, keyword, so I was assuming that it would be, like, a function that was declared somewhere here, but I guess it's not. Okay, but anyways, what do? We go to email to name. So the key is going to be email, and the value is going to be name, just like the dictionary's title. I don't want to use the word name because it's right there, but the dictionary's title is email to name, so we're mapping the email to the name, okay? Email to ID is going to be the same thing, which is getting a new ID. So I'm okay, I guess you just have to implement your own functions here. But anyways, I'm assuming that this one is just going to be something like increment by 1 each time or something like that. Maybe you have like a static variable that just like increases by 1 each time the function is called and returns that value. Okay, so you map that to the email to ID, then parent email equals email. Parent with key, the key is email, and the or the value is email. Okay, I don't quite see how that helps us. Rank is 0. I don't know what parent or rank does. So then next step, find and group emails. So default dict. Now is default dict different than just declaring a normal dictionary up here? I probably need to look into that. Of lists. Email. For email. Jeez. For email and email to name. Root equal. For email and email to name. Okay, email to name was declared here. I'm iterating through each of the keys in this dictionary, which will be each of the emails. Root equals, and root was declared where? It declared nowhere. Equals find email. What is find? Find is not a standard either, is it? No, it's find is not a standard. Okay, so find also needs to be implemented by yourself. I don't know what find is going to do. I guess it would just, I don't know, it just returns root for some reason. And then, of course, you just put root in, obviously, you just put root in email groups and then append it. There you go. Ha, we got it. Yeah, that makes complete sense. I can't tell if I'm just like exhausted or if this doesn't make any sense. Yeah, I want the detailed implementation. Because this doesn't make any sense. Class union find. Okay. Oh, you have to be kidding me. our our class union find. Class solution. So this is just a helper class, and yeah, I think this is a tomorrow question. So moving forward tonight, I am going to look up. I'm going to watch some videos to try to figure out what a union find data structure is. I am going to look up a solution to this problem that uses that union find implementation, and then I am going to try to understand this problem more tomorrow, because there's no way I'm going to be able to go through all of this and make any headway, because if I don't know a particular data structure, I mean, if my head was fresher, I could probably like go through it and then eventually a light bulb would click, like, oh, okay, I see what's going on. But as of right now, if I went through this, I don't think I would be able to get that light bulb moment. Yeah, I'm tired. I'm gonna go to sleep. Um, yeah, I'm sorry. I'm sorry. This was probably a pretty boring video. Just kind of like me not understanding anything. Um, yeah. Anyways, I'm gonna head to bed. I'm tired. Um, I'm gonna watch some videos tonight about union fines and how to solve that. Which question was this? I don't like this question. I like it insofar as I'm definitely gonna be learning a lot from it, but I don't like it insofar as like, oof, I failed. Anyways, 721 accounts merge. Tough problem. Anyways, yeah, so thank you guys for watching this video. If you actually watched it. Uh and I hope you guys have a wonderful rest of the day. And yeah, anyways, my name is Timothy Lee Grant. I will see you tomorrow where I'm going to be talking about this problem again. So we're going to try this problem tomorrow in the morning with a cup of coffee. So see you tomorrow.